we determined that the vector QR, because PQ plus QR equals PR, follows that QR equals PR minus PQ, and subtracting the coordinates of PQ from the coordinates of PR of the components, we get negative 2i plus 2k, so that QR is negative 2i plus 2k. Now, knowing the dot product, and if you know the dot product in 2 dimensions, which was provided in the review that you've completed, it won't be any surprise that the dot product in 3 dimensions follows the same pattern. We simply multiply the I component of PQ by the I component of QR, obtaining negative 3 times negative 2. The J components, which are 6 and 0 in this case, and the K components 5 and 2, and we find that this is 10 and 6, which is 16. So that PQ dot QR is 16. Now, we also know that PQ dot QR equals the magnitude of PQ times the magnitude of QR times the cosine of theta, where theta is the angle between the 2 vectors. Now, in this case, let's take a peek back at our original picture. I have theta mislabeled here. I'm going to cross that out. Theta is the angle, in this case, between PQ and QR. And PQ is here, QR is here, so right here is our angle theta. And we're going to try to find the cosine of this angle. Now, this angle looks like it's fairly close to a right angle, which means that we would expect the cosine to be fairly small. Cosine of a right angle is 0. Let's see what we get. Now, the cosine of theta then would be PQ dot QR divided by the magnitude of PQ multiplied by the magnitude of QR, which in this case is 16. And the magnitudes of PQ and QR, we have square root of 70 times the square root of 110. Now, I'm not going to figure that out. 70 times 110 is 7,700, fairly close to 8,100. The square root of 8,100 is 90. So I'm going to say that this is a little less than 90. If it was 80, 16 over 80 is 0.2, so I'm going to call that about 0.22. It would follow then that theta is the inverse cosine of 0.22.